Hi everyone. So in this session, we will know that if the data will have normal distribution or not, or how determine if this data has a normal distribution or not. We will use like three cases. One, using a histogram. If this histogram in the bill shape, so if we have like a histogram like this, somehow like this maybe. So this one, in this case, we can say this is close enough to normal distribution. Maybe this is the best case scenario for the normal distribution. And then if we have outliers, so if we have more than one outlier, then might be this data not coming from normal distribution. But if we have data, the data has like bell shape, and then we don't have outliers, or we have just one outlier, then maybe we will construct normal quantile plot or QQ plot. Okay, so QQ plot is a plot that has a graph of some points X and Y, where the X is the original data, and then Y, it will be the Z values for this data set. And we will see how we will do this one. So for example, if we have a data like this, 125, 229, and then 234, 236, and then 257, and then those the values for Z, and we will know how to calculate those values manually and using technology. So now we have like a point. So this, the first point, it will be 125 and negative 1.28, and it's kind of scatter plot. You know, we did the scatter plot. So we will have like X values here and the Z values here. And if those values seems to be like on straight line or close enough to the straight line, then we'll say this data coming from normal distribution. We'll see it in details how to do that. So the first one, we will do the histogram. So if we do the histogram and the histogram is far enough from bill shape, then we can say this data is don't have a normal distribution. Okay, so and then the outliers, if we have more than one outlier, then we conclude the data might not have a normal distribution. But if the data is, as I did say, if the bill shape is for the histogram was like normal distribution or in the bill shape, and then we have only one outlier or we don't have any outliers, then we will use normal quantile plot. Okay, so then when we do the normal quantile plot, so we have two conditions to say this is normal distribution. Okay, so if those dots, that the points we did here, of those dots are close enough to this straight line, this is a good indicator that this data coming from normal distribution. So this one condition. So one, we must have these points not far or close enough to that straight line. And then the second condition, those dots will be distributed randomly around this straight line. Okay, so the randomly distributed, so they don't show any pattern. Okay, and then it will be not normal distribution if those values of those dots don't lie close or they are not close to that straight line, and then we have some symmetric pattern around this straight line. So let's say for this one, this is the first example here. If you look to this example, if you look to this histogram here, the histogram somehow it's close to the normal distribution, right? It's close enough. So you know that when we try to find curve, just we connect the midpoints, right? Connect the midpoints using a curve, not using a curve, so we can get the density function for that distribution. So now this is close enough, this histogram close enough to normal distribution. Also, if you look here to this straight line, we see that all these dots really close from the normal distribution, right? Close from that straight line. So maybe just we have one value here that's far from the straight line, but the rest is close enough. And then also we don't say any like symmetric pattern for this one. So those values just distributed randomly around this straight line, okay? So now we can say that, yes, this is a norm, this data coming from normal distribution. And then if you see this one, the second example, if you see the histogram here to the left, this is, if you remember, that the uniform histogram, right? Because all data set, they have the same frequency here, or the frequency equal. So this data coming from uniform distribution. Also, if you look to this QQ plot, right? Now, yes, the data, the dots is close enough to that straight line, but if you see that is symmetric pattern around this line, if even you look the distance between those two dots, exactly the same as the distance here, right? So it's the distance between those dots, exactly the same. We start low and then we exceed the straight line and then we go back and then we go up, which is a symmetric pattern. So this data is clear from the histogram. It's not from from a normal distribution, and also from the QQ plot. So this one is not normal distribution, or we can call it uniform distribution here. There is another symmetric pattern, is not a straight line pattern, which is here, okay? The third one, if you look to the histogram here, it's clearly this distribution is somehow skewed to the right, which is like this, right? So now we have two things in this histogram. One, this histogram is not in the bell shape, so this is not normal distribution. This is one, right? And then something else, if you look here, this value here with the frequency equal to 1, it might be outliers, right? Because we don't have any data set from here, from 1 to 1.5. So this frequency here equal to 0, and then we have a value with the frequency equal to 1. That might be outliers, and might be just if it is just on, if we have one value between 1.25 to 150, then might be that's okay, which is 1. But if more than one value, then might be outliers. Okay, outline. Then if you look here, all those values is really far. Let's say all those values is really far from the straight line, right? Here and then here. Those really far. So this is not normal distribution, clear. It's not normal distribution skewed to the right, and this is not a normal distribution. Okay, so the tools that we want to use to determine normality, first one, histogram and outliers. Okay, so now if we have normal distribution, or if the requirement for this normal distribution is not too strict, then if we have the bell shape somehow close to normal distribution and we have only one or zero outliers, then we can treat this population as that has a normal distribution, right? But if we want more evidence that this normal distribution, we can use the data as a normal distribution, then we can use QQ plot, and I will show you how to use stat disk for to calculate or to find a QQ plot. And then they have like some other methods using like chi-square, Kolmogorov, Seminarov test, and other tests. So I don't think that we'll see them in those sessions. Maybe we'll see like just maybe Ryan Jr. test here, but the rest we will not study them in those in this course. And then how to find, or how to construction the normal quantile plots manually. So the first step we want to do is just to arrange the data. Okay, to arrange the data from lowest to highest. Okay, so this is the first step, and then we will see the sample size n. Okay, so we'll see the sample size n, and then we will find like this sequence depend on how many data sets we have. So we starting from 1 divided by 2n, and then 3, 5, 7 divided by 2n, and so on. So this one, if we continue, it will be 7 divided by 2n, 9 divided by 2n, and so on, right? And then, so these values will be the cumulative area to the left of the corresponding sample values, which is we will see in the example soon. And then the third step, we will find the z values for the z for those values, z score for those values, and then the last one we will match them. So this one will be x, it will be the original data, and then y, it will be the z score. Okay, and then we'll see how when we like draw them together, graph those values together, and then we will examine the normality or the normal quantile plot, use the criteria given earlier, right? So if we have like those two conditions, the first condition, the dots close enough to the straight line, and then the second condition, those dots distributed randomly around this straight line. So let's see this example in your book. So here in this example, we have this data set. Okay, we have 5 values, and we'll study the same data set, and later I'll show you how to use stat disk for this one. So let's see. So the first step we did say to arrange this data, which is I put them here, arrange them. And then how many values we have? 1, 2, 3, 4, 5. So now n equal to 5. So, and then we need to find this sequence, right? 1 divided by 2n, and so on. So 1 divided by 2n, and then 3 divided by 2n, 5 divided by 3n, and then 7 divided by 3n, and then 9 divided by 3, sorry, 2n. It will be all of them 2n here. 2n, 2n, and then 2n here. So how many we have? We need 5 values. 1, 2, 3, 4, 5. So let me put them here. So we have 1 divided by 2n. So 2, so n equal to 5. So it will be 1 divided by 5. 3 divided by 10, sorry, 1 divided by 10, 3 divided by 10, and then 5, and 7, and then the last one. So this is basically 0.1, and this is 0.3, and this is 0.5, and this is 0.7, and this is 0.9. So now the next step, we will find z values for those. So let's z values here, or z score. Okay, so now for z scores, we can use step disk, right? So let me show you how can you use those. So now come here, analysis, normal distribution, probability distribution, normal distribution, and go to the area, right? Now, so we have the area, and then we will try to find z values. So we didn't know how, when we have it, we won't have z values, we can find the area, and now we have the cumulative area to the left, and then we can find the z value. So at 0.1 equal to negative 1.28, sorry, we take just 2 digits, and then the next one, it will be 0.3, it will be 0.52, and then the next one, .5. Can anyone tell me at 0.5 what the value of z will be? So remember, this is the area under the curve. The area under the curve equal to 0.5. We did say that the area under the curve equal to 1. So if we take the area under the curve 0.5, it will be the half of that curve. The area under the half of this density curve, and then the value of z will be equal to mu, all right? And the mu of standard distribution equal to 0, which is this value here, right? Okay, and then we have the next one, we have 0.7, which is 0.52, and the last one we will have 0.9, which is 1.28. So let's go back here. It will be the first one, negative 1.28, and then negative 0.52, and this one 0, we did say, right? And this is 0.52, and then the last one, which will be, sorry, 1.28. Now we will graph those two. This one, the original data, and z score. I don't know, maybe we can do it like here. I'll show it like not so like this. Somehow, so here, let's say we have 1 at 100, and then 125, 150, 200, 225, and then 250, and then 275, maybe. And then here, maybe we have negative 1, 0, 1, and so on, right? So the first point will be, let me write them here so they will be clear to you here. It will be, the first one will be 125 and negative 1.28. So 125 and somehow some like here, maybe. The next one will be 229 and negative 0.52, negative 0.52. It will be 229, which is somewhere like here, maybe, and then negative, maybe something, something around here. And then the third one, which is 34, maybe here, and 0, which is here somehow. And then the next one will be 36, which is almost the same place here. And then 0.52 here. And then the last one, it will be 257 somewhere here. And then 1.28 might be here. Okay. So now I don't know if we put some straight line, might be, will be like this. I don't know, might be something like this. And if you look here, might be we consider those here, this value, especially this value, somehow far from that straight line. So might be we say this is not from normal distribution. Let's say if we use stat disk for that. So we come to the data set here, maybe clear. Okay. And then we take this data set, which is, we did say 125, 229, 234, okay. Okay, so now come to the data, I believe. Maybe here, normality assessment, which is this one, and then we choose the first one. This is the graph we did. So this is might be somehow not normal. The histogram is okay. It's not far from the normal distribution, but if we look here, we will find clearly that this not really from the normal distribution. So if we look to the decision here, so at alpha equal 0.05, we reject the normality, which is the data. That's mean the data is not from normal distribution. Okay, and then the other test was a Ryan join test, which is one of those we can use, which is the decision we did take right now. So if you look here to the test we did, which is using the Ryan join test here. So if you see this value is equal to 0.84, and the decision and those critical value, it's between so it will be, it must be greater than 0.88. So for the critical value 0.88, so that the status, if this value statistic test, which is this value, it must be greater than 0.88 if we use alpha 0.05. So now we reject the normality when we have sigma alpha equal 0.05. But if we have alpha equal 0.01, might be we say, okay, yes, this is a normal distribution. This data coming from normal distribution. Okay, so now we'll see this example here, which is the same example. So this example, we'll see it. Okay, I'll see. Let's see what we have here, and then we can do the. We can see it in the stat disk. So now, if you look to this one here, from the histogram, we clearly that this is this distribution squeeze to the left, right? And maybe we have some gaps here. So maybe this is a kind of distribution, and here we have distribution. But if we consider the whole data set is one distribution, and the curve will be something around like this, right? Which is clearly this distribution is not normal distribution, right? And here also, you can see those dots is far from the normal, far from that straight line. And also, if you see here, we have some gaps here, right? So here we have some gaps, which is this gap in our data here in the histogram, which is this one here. So clearly, this data is not from normal distribution. So so this is skewed to the distribution. If we look to the histogram, the distribution is skewed to the left. And then the outliers, they said we have, okay, 20 outliers in this data set, which is, we did say we accept 0 or 1 outlier. Okay, so now if we're gonna use histogram, this is skewed to the right, skewed to the left, which is not in the bell shape, right? And then the outliers, we have more than 1 outlier. And then even using QQ plot, and we don't need to use QQ plot, because we have this one and this one, the histogram and outliers, both of them tell us that this distribution is not normal distribution. But even if we use the QQ plot, still we can say this data is far from the straight line. Okay, so let's see now, let's go and see this distribution. The same data set. Let's come here and we go to data set, and our book is the second one, right? Elementary Statistic 13 edition. So we choose this one, and then we go to the same example, which is number 23 here. So this is the data set, and then we have this variable. So let's go to here, data, and then we go here, and then choose the third one, evaluate. So this is the data we have. This is the same example. So now we did say from QQ plot and from histogram clear that we don't have normal distribution, or this data is not from normal distribution. Okay, let's see here. Here we reject the normality. The decision which we reject the normality with alpha equal to 0.05 and 0.01, both of them. And then so if you see here, the possible outliers, the number of outliers might we have. So let me see here, how can we see those 20 outliers? So let's go here again to the data, and then we go to box plot, right? And then find the third one. So box plot. So this is our box plot, right? So now let me write them down. Maybe we can do calculate them. So the Q1 equal to 227, and Q3 equal to 248, right? So those two values, and then the modified box plot. So which is here the values. If you count those stars, you will find them as 20 data set, 20 data set. So let me see here. Let's go back to the same test we did, which is here, and then we choose the same one. Okay, so they say how many values or number of here, number of data values below Q1 by more than 1.5 equal to 20. 1.5 times IQR, right? So let me go back here. So let me go back here and then maybe, and let me find some place that I can write. Okay. So now the value of QR, if you remember, this is equal to Q3 minus Q1, which is equal to 248 minus 227. And if we calculate those values, maybe it will be, okay. This is equal to 21. So now, any value less than Q1 minus 1.5 IQR, which is equal to Q1 equal to 227 minus 1.5 times 21. So it will be 227 minus 31.5 equal to. So now any value smaller than this value, it will be outlier, okay? Any value less than 195.5 will be outlier. So let's go back here to our data set, to the data, sort data, and then we come to this one. Let me sort this one. Okay, so now here, this, sorry. So this variable here, try to find the number of data set less than one. So let me sort here. Yes, now it's sorted. So number of the data set less than 195.5, which is, if you go here, it will be about, oops, how to make it smaller. Yeah, so here, it will be, this is 20, yes, from here. So it's just 20 values, right? Which is the next one, 203. So we have 20 values of outliers, okay? And then last thing, maybe just I want to mention, if we did check that data and we find the data is not from normal distribution, in some cases, if we do some transformation to that data, we will get normal distribution too. So we check the data, we check the histogram, and then the number of outliers, and then we do the QQ plot, and then of all those, we got the conclusion that, okay, this data is not from normal distribution. What we can do next, then we can try something else, which is do some transformation to this data. One of those common transformation is just take the logarithm, okay? So take the logarithm of x with base 10, and then we check the normality again. If we find those data after the transfer, after we apply that transformation is normal distribution, then we say that yes, then the original data called log normal distribution, okay? But if we couldn't find any transformation that make this data normal, then we have to go to non-parametric methods and apply them. That's it for now, and thank you.